guys, let's go check this question so that you guys will understand what do you need to do in order to analyze these kinds of concepts. So Nsova's question reads as follows. It says, simplify the following expression to a single trigonometric ratio of theta. Right. So what you're looking at here is a question that has got a lot of concepts of trigonometry that are involved on this, and we need to try and find all this in the form of a single trigonometric ratio. So let's begin first of all by analyzing the different parts that exist in this question. First of all, when you look at it, you will notice that you've got things such as 360 minus theta, you've got things such as theta minus 360, you've got 90 degrees plus theta, and so on and so on. And then on the other part, you have 163 degrees divided by cos 73 degrees. So what we need to understand here is that this kind of a question, guys, is what uses what we call reduction formulae, right? Very powerful. I know a lot of you have been trying to understand where exactly in grade 12 do reduction formulas feature. So this is an example of a grade 12 question in solver that use a reduction formulae, right? Now, in this question, let's see what the story is going to be in this case. First of all, you need to know your 4 quadrants. You need to know that in the 4th quadrant, cos is positive. In the 1st quadrant, all ratios are positive. And then here, sine is positive, and then tan is positive. You also need to know that we've got 0 degrees, we've got 90 degrees, we've got 180 degrees here, we have 270 degrees, and then you've got 360 degrees. With this, you are able to do a lot of very interesting simplifications of what we are currently working on now. One of those things is the one that I want you to pay attention to. Every time you're going to deal with an angle that is greater than 360 degrees, the idea is you must subtract 360 degrees in order to work with it. The other one is if you've got an angle that is smaller than 0 degrees, which means if your special angle is a negative, we advise you to always add 360 degrees to it. If you can do this, you will always be able to simplify the questions without any challenges. So as I'm looking at this, I'm going to be looking for that. If they say sine of anything minus anything, I just check which quadrant is this thing located, and then after finding that out, I'm going to then decide whether the answer is going to be a negative or a positive. Remember, if you're using any of the angles on the vertical line, which means if you're using 90 degrees or you are using 270 degrees, your ratios changes to its core ratio. Please keep that in mind. Right. So now let's see what the story is with this one. I'm given in the first part 163 degrees. So I want to figure out something very interesting on this. 163 is an angle, guys. It's an angle that is in one of the quadrants. If I ask you which quadrant is 163 in, you guys will agree with me that it is between 90 degrees and 180 degrees. So I'm going to reduce that to the sine of 180 degrees minus something. What is it going to be? So you're going to call a calculator and you ask yourself, what is 180 minus 163? You get an answer of 17 degrees. So that is actually 180 minus 17 degrees divided by, on the denominator, we've got cos 73 degrees. Now, to avoid having too many angles that are not the same, right, you can have your 73 in 2 different ways. You can call it 90 minus something or 180 minus something. But it's going to be wiser for us to call it 90 minus something because of the fact that if we do 90 minus 17, you get a value of 73, which means that 17 degree comes back again. We're now going to be looking at something that has got the same angle as what our numerator has. So this is going to be cos of 90 degrees minus 17 degrees. And once you have this kind of a setup, you know for a fact that one way or the other, this will cancel each other because they both have that value of 70 degrees on them. And then we're told that this is actually plus something very exciting, yeah? The sine of 90 plus. Now, 90 degrees plus is an angle in the 2nd quadrant, and in the 2nd quadrant, sine is positive. But because of 90, our ratio needs to change. Remember that when you are working with 90 degrees, and when you're working with 270 degrees, your ratio changes. Sine changes to cos, and cos changes to sine. So this I'm going to write as positive, the sine of exactly, not sine, but cos, because it is changing to its core ratio. So you need to change sine to cos because you are working with 90 in solver. So it's going to be cosine of theta. And then the second one has got on it the tangent, guys. The second one has got the tangent. The tangent squared of theta minus 360. Now, because of the square, I don't care in which quadrant this angle lies. I'm just going to simplify it to exactly the tan squared of theta. It's going to be positive because anything squared will always be positive. On the denominator, I've got 360 minus. That angle lies in the fourth quadrant, and then in the fourth quadrant, cosine is positive. So I'm going to simply sit with the cosine of theta. Very powerful stuff based on what we're looking at right here. Now, what remains after this is just for you to identify anything that look identical. If you find anything that looks the same as the other one, you just simply cancel them out. Everything else works out quite nicely. So let's see what is going to happen in this case. You'll notice that cosine divides cosine out, and then the left part there, sine 180 minus theta, can be reduced to exactly sine 17 degrees, which is in the second quadrant, so it remains positive. And then on the denominator, the cosine of 90 minus will change again. We told you once you're dealing with 90, the ratio changes to its co-ratio. So this will change also to the sine of 17 degrees plus on the second part, we are left with just tan squared of theta. That divided by itself, the answer is 1 plus the tan squared of theta. Now, what will this actually amount to? They said they want a single trigonometric ratio. Now, if I wanted to get this to be a single trig ratio, I could simply change this to 1 plus sine squared theta over cos squared theta. And then this is 1 over 1. You can add those, and then you are simply going to have a very simple thing, which is going to be the cos squared of theta, which is your LCD. And then after this, 1 goes cos squared times. Cos times 1 gives you cos squared theta plus cos goes once into cos, and then you're going to get sine squared of theta here. And when you simplify this, it's going to be on the numerator 1 divided by the cos squared of theta. Now, I got this to be a single trig ratio for a lot of kids who are not doing IEB mathematics or those who are not doing advanced program maths, right? This can be simplified further if you use any other concept that involves the reciprocals of trig ratios. But for you, if you're not doing any advanced math, this is where you would need to stop. But if you were doing external mathematics, then this is how the final answer was going to look. 1 over cos squared can be written as sec squared of theta, and this would be the answer to the first part of the question. Right, now we're going to go to the second part of Nsovo's question. This part reads sine squared theta cos theta divided by tan 2 theta into sine squared minus cos squared. We need to simplify this to one ratio. Let's see how far this is going to go. So on the numerator, I've got sine squared theta. So I'm going to write that as sine squared theta multiplied by the cosine of theta divided by, on the denominator, I've got tan 2 theta there, which I'm going to write as tan 2 theta multiplied by, but this part you see here is what we call the expansion of a double angle of cos. So cos 2 theta can be expanded to 3 versions. One of those versions is the one you're looking at, but it's not written in the right order because it's supposed to be cos squared theta minus sine squared theta. Please keep that in mind. Those are the 3 ways we can expand the double angle of cosine. So I'm going to take that one that I'm looking at now, and I will write it. Because of the fact that the order is swapped around, it means it is actually negative double angle of cos. So negative cos 2 theta. Right. So let's see what will happen if you continue trying to simplify this further. On the numerator, I've got that sine squared theta times the cos 2 theta, not cos 2 theta, but cos theta right there, right? Sine squared theta times cos theta divided by. Now, tan 2 is simply sine 2 theta divided by cos 2 theta times. This is actually negative cos 2 theta divided by 1, right? So when you simplify this further, you're going to notice that the double angle of cosine cancels the double angle of cosine. You're left with negative on the denominator there. So this is simply going to amount to something very useful. It's going to just be sine squared theta divided by negative sine 2 theta. And then we left again on the top cos theta there. Very, very simple stuff, right? Now, after this, we just try to look at what we're looking at now and try to see what more can we do with what we have. Now, I tell you what, this question was not copied correctly. So if I look at the numerator there, I notice that we actually have sine squared instead of sine 2 theta. So this part was supposed to read sine 2 theta according to the question that Nsovo sent to us, right? So if you do that, then you notice that that's not a square, but it's sine 2 theta right there. And if you add that 2 theta there, then the sine 2 theta cancels out the sine 2 theta, and then you're left just with negative cosine of theta, which is the solution to this question, right? So it's important for you to understand that when you've got these kinds of ratios and we ask you to simplify it to a single trig ratio, you're going to simplify as much as you can until you get to a point where you are left with exactly one ratio. You're going to apply all your concepts, your double angles or reduction formulas, and all the other identities that you've learned from grade 11.